Miller Mahdi from 8451 here. Welcome to another episode of The Uplow'd. We're glad you're here. Each month we dig into the world of AI, thick data, machine learning, data science. We invite you to stick around and let us know what you think. Keep an open mind and stay curious.
Welcome to The Uplow'd by 8451. I'm your host, Dan O'Keefe. Today we're talking about the pedagogy of data science with Brad Boehmke. Welcome, Brad.
Thank you. Thank you for having me.
Pedagogy. We'll let them in on that inside joke later, right? So tell us a little about yourself and your background, Brad.
So after college, I was active duty Air Force for about 10 years, affiliated with the Air Force one way or another. Active duty for 4. I was in the finance career field, which they have a section of that career field that is called cost analysis. And so cost analysis is doing a lot of life cycle cost estimating. So you think we need to buy a new weapon system, a new aircraft. A recent one was a new Air Force One replacement. And so we are actually looking at what's it going to cost to buy and then sustain that aircraft for 30 years.
Interesting. So you had something to do with the purchase of our current Air Force One aircraft, right?
Yeah. Actually just went into contract with Boeing.
Interesting. Okay. Any cool stories you can tell us, or would you have to kill stuff?
No, just really expensive.
Okay. So. Gotcha. All right. Tell us a little bit as well about your affiliation with the University of Cincinnati.
So while I was still working for the Air Force, doing a lot of this work with cost estimating for weapon systems, I had kind of a unique opportunity to go to the Air Force Institute of Technology, which is up in Dayton, Ohio.
Mm-hmm. Right, Pat?
Right, Pat. Yep. To get my PhD. And so spent couple years doing that. Afterwards, I was fortunate to go on as assistant professor up there at AFIT. I taught there for about 2 years. During that time, I was able to connect with the dean with the business analytics program down at UC. I had written a book on R that...
you wrote a book on R?
I did write a book on R.
How old were you at this time?
Well, old enough to at least get to that part of the alphabet.
Gotcha. All right.
So he found the book quite enjoyable, and he wanted his students to get that. It was on data wrangling with R, right? So
okay. Sure.
He wanted a lot of his students to kind of get that exposure. So it brought me in, and I taught data wrangling with R for a few years down at UC. Yeah.
Interesting. All right. Great. Any more books ready to be published?
Actually, yeah. So a colleague here, Brandon Greenwell, another 8451er, we are about 75% through a hands-on machine learning with our book.
Very interesting.
So we
all right.
plan on releasing that this summer. Yep.
That's cool.
Yep.
All right. Awesome. We all get a free copy? All the
of
listeners?
Course, yes,
right.
yes.
Sure. Awesome. Brad is one of 8451's directors of data science. You've been charged with developing the company's data science pedagogy, right?
Yep.
And just for those of us who aren't as learned as you, pedagogy means teaching, correct?
Right. And we kind of use it a little bit more vague here. It's
okay.
More about the idea of how do we upskill, how do we train our data scientists? So we have a lot of data scientists, whether it's they've been here for a long time and they've used tools that we are transitioning away from, or we have folks coming in from universities,
right,
and they get exposed to some of the tools, some of the methods, but not all of them. So it's like, how do we get all these folks kind of on the same page of what open source tools do we use? What are the methodologies that we want to apply?
Gotcha. So speaking of the fact that you've got all these folks coming in from different places, different areas of study, how do you handle the different needs for employees to train within their pre-developed skill sets versus exposing them to the new skills?
Yeah, so we kind of look at our data scientists in kind of 3 buckets. So we kind of categorize them as we have folks that focus heavily on insights. And the way to think about that is these are the folks that are doing a lot of like storytelling with the data. So a lot of aggregation, a lot of visualization. They're the ones that are often presenting to non-analysts, trying to communicate some of the trends that we see in certain products.
Would those non-analysts be like CPGs?
Correct.
Okay.
Yep.
Right.
Kroger leadership.
Gotcha.
Yep.
Okay.
And then we have folks that focus on statistical modeling, machine learning. So those are the folks that have a lot of education in stats models, algorithms, some of the methods that we like to deploy internally on certain types of analyses. Then we have a third bucket that focuses on the technologies, right? Okay. So this is really focusing on the tools that we use, whether it's R, Python, different kind of other programming languages, or specific tools that we're using. So we kind of have like those three categories. A lot of the education and training that we do will go across all three. We kind of have certain expectations that everyone is skilled on certain fundamental tools or methods. Right. But then we offer a lot of training and resources specific to one of these buckets so that, they can kind of upskill higher in that bucket.
Gotcha. And then what are some of the principles you take into consideration when developing the actual material and format for each training session?
So since I've been here, we've really changed how we do a lot of our training. When I first came in, there was a lot of typical presentation style of PDF or presentation slides, walking through, and it wasn't a lot of hands-on coding. We have changed a lot of our training where they're code-based living products. Basically, what you see as far as training material, we're developing a lot of that with code, and there's a lot of benefits with that as far as maintaining, allowing our training material to kind of ebb and flow as changes we have with the folks coming in with different skill sets. As we change business emphasis on certain things, we can easily pull in different new data sets, new business problems for case studies, stuff like that. And as far as the focus of our training sessions, we have really gone from like having these big one-day training sessions, which we still have some of those going on, but we've kind of isolated down to like 2 hours is a great window to have a training session. And we try to have each of our workshops, and we continuously have workshops, once a week, every other week, but it's really specific on a certain type of topic that we want to cover, and it's very hands-on, right? So everyone in there is going to be, applying that machine learning algorithm with code, right? We want them to walk out of that training session having written the code, having applied the algorithm that we may be training, being able to interpret the results, and so on.
So it's like a workshop. Those 2 hours is more like an active workshop.
Yeah, so a lot of our trainings have gone from like, rather than just being like, here is intermediate R or intermediate Python training, to like, here are this segment of 12 different workshops that make up intermediate Python, but we do them in very small focus sessions.
Okay. And so we've just talked a little bit about the training sessions. Can you tell us a little bit more about the topics you're covering? You mentioned R and Python, right? Yeah,
so we have a couple different types of methods of doing training, right? So we have very sequential training. So these tend to be focused on topics we want our analysts to get real deep knowledge on, right? So this will include tools such as R and Python. We have like intro, intermediate, advanced level trainings. Machine learning is one that's a very sequential training. So each session kind of builds on the next to kind of get that deep fundamental knowledge. But we also want our data scientists kind of have like this very strong breadth of knowledge, right? So although you may be like an insights data scientist or statistical modeling, there's a lot of tools or methods that you should be aware of that you may not have an immediate need, but it's going to kind of give you a breadth of understanding what's going on. And that allows you to kind of think, well, I remember seeing this. This is something that I wouldn't normally do, but I could apply it. And so those types of trainings are much more kind of one-off. And we typically have those once or twice a month. And that can include building web apps with like R Shiny or Flask, which is a Python product. It could be interpretable machine learning, right? So they've gotten smart on how to apply different algorithms, but it's like now, how do we kind of open up this black box and try to get some understanding as to what's going on with the information in this model? It could be text mining. We do have some cases of doing like natural language processing, text mining in the company, but it's not as prevalent as some of the other types of analyses. But we want to expose all our data scientists to that kind of a capability.
You mentioned interpretable machine learning training. What is that exactly? And that is a general session currently, correct?
Correct. Yeah. So interpretable machine learning is so we have kind of a set of algorithms that we kind of have as a general toolkit for our analysts, right? So for our predictive modeling, pretty much the analysts are going to be starting off using a regularized regression, random forest, gradient boosted machine, and a little bit of like deep neural nets. The problem, so you got two things.
Right.
Great algorithms, very powerful, very accurate with prediction. The problem is they get very complex. And it's not as easy as some of the other algorithms to understand what is influencing that prediction, right? So think about your customer at Kroger, and we are predicting that you should get this coupon, right? So the question is, well, why? Right? What is it about you?
Why am I getting it right?
Right.
Exactly. What directed this coupon to me?
Exactly. Right. So when you are using a more complex model like a gradient boosted machine, that's not easy to parse out. Right. So interpretable machine learning is like, how do we kind of open up these algorithms, these black box type of algorithms, and try to understand like what's influencing that predicted value. Right. What is it about your attributes, your characteristics that may be influencing why we are predicting you're going to use this coupon, right?
Okay.
And we could look at you as an individual. We could look at groups of people, right? So maybe there's different locations that are reacting differently to products, right? And so we can kind of parse that information out by doing interpretable machine learning.
Gotcha.
Right. So it's all about how do we interpret the model and the output.
And so what's the end product or end result of that particular learning, interpretable machine learning?
Yeah, so there's multiple different ways to pull out. So some of the fundamental ones are if we look across all our customers, right, and we can have these predicted outputs based off of our model. We want to understand like what characteristics in general across all our customers that are really influencing our model, right? So this could be like any kind of a common characteristic. Maybe it's distance from store. Maybe it's a certain type of demographic information that's saying like, on a whole, this is a very influential characteristic of all our customers, right? We can also look at, well, for that characteristic, let's say it's income. Let's look at how does your buying choices change across that spectrum of income, right? So we could look at from lower income all the way to upper income. What does the amount that you buy or the type of products, how that changes, right? How does that change based off of that income, right? Okay. And then we can start getting down into very specific things, and that gets down to like you as an individual customer, right? Maybe our model is saying that income is a very highly influential predictor variable, but for some reason you are completely the opposite of that, right? Maybe you are a lower income person that is buying things in a way that is different than a lot of other lower income folks, right? And we can say, well, maybe why is that? What other unique characteristics about you are determining that?
So I'm curious. For me, actually, there are 3 Krogers. They're fairly equidistant from where I work and live. That I could go to either one almost any day of the week coming back from work. Right? Can interpretable machine learning tell why I choose whichever location on whichever day? Is that
it can definitely help.
Interesting.
So we actually had a colleague, Greg Anderson, here that he did a fantastic analysis that looked at spatial analysis. So if you were to look down at Cincinnati or some large metro, you could look at where all the Krogers are. You could look at where competitor stores are, and a bunch of other information. And then you can look at where are all the customers, right? You can kind of look at from a spatial analysis perspective, are there certain components that are driving maybe why you go to a store, or maybe what's influencing you from buying more at Kroger, maybe because there's a competitor that is closer by, right? Or maybe there was a competitor that was closer by, but since we did a remodel, even though we're a little bit further away, we kind of see this, we see this uptake in more behavior or more consumption based on that. So
interesting. Okay. So we've learned a little bit more about interpretable machine learning. What is writing functions in R, right? That's another session, correct?
Yeah. So we've actually had a couple of sessions that are just writing good functions, right? So that one was writing functions in R. We've had one in Python. And the whole idea is as we get more folks coming in and writing code, you can definitely write really bad code.
Right.
It can work, but it can smell really bad just because it is not flavorful. So we are trying to get our analysts to not necessarily standardize, but understand how do you write not only code that works well and efficiently, but then also code that is easy to read and understand, right? So a lot of our analyses can be passed on to other analysts, right? So as we have analysts that move to different parts of the company, we want folks that are coming in maybe to this team to be able to look and say, hey, I completely understand what's going on with this code because all the functions, all the code is written very well. So that session was all about like, how do we just write good code, right, for functions? Yeah.
Interesting. Does R stand for something else, by the way? I've always been curious. It just seems Python's a cool name for a coding language, but R is just,
Well, so Monty Python is the reason that.
Gotcha,
Python,
right. I remember that, yeah.
R is, predecessor was S, right? So it was, and then you had the two folks that were primary authors of transitioning from S to R, had their names, I can't remember off the top of my head, but their names started with R, so.
I'm almost sorry I asked that question. Yes. All right. Well, let's move on to the next one. Introduction to containers and Docker. That sounds like a warehousing, application, right? Or session. So what is that exactly?
Yeah. So when you think about a lot of the analyses that we do across the company, right? So lots of times our analysts are writing or doing analyses that is just exploratory, right? And it's not necessarily that people have to reproduce it, but it's like they're just trying to find some information out. We have a lot of code that we are trying to write that goes into production, right? And when you start talking about moving stuff to production, it becomes a lot more important that things are reproducible, repeatable. And so the idea behind like containers and Dockers, the way that I like to explain it is think about IKEA, right? So we had a gentleman, Ethan Swan, that did the training. And he kind of described the idea of, let's say you go into someone's house and you see a piece of furniture, right? Custom piece of furniture, and you're like, oh, I love that. I want to rebuild that. How do I do that, right? Well, it's going to be very difficult to reproduce, right? But if that piece of furniture is IKEA, right? You go to IKEA and you get this this container, this set of stuff that has everything you need to reproduce that piece of furniture. And when you put it together, as long as you can follow the pictures,
look exactly
it should look just like it, right? So the idea behind Docker and containers is that when somebody runs this application, this set of code, you want to make sure that they have the same dependencies and the same requirements to reproduce that output and get that application working. A container is basically a way that you bundle up all the dependencies and requirements of that application so that it fully reproduces.
Gotcha. So standards, basically.
Yep.
Gotcha. Okay, great. Well, thank you for that, Brad. And now that we're through the light and airy part of the conversation, it's time for the hard stuff. It's time for the 8451 lightning round, where we ask you a series of 8 random questions for 51 seconds. Brad, are you ready?
No.
You need time. You want to stretch?
Go. No, we're good. We're
all right,
good.
You sure? Need a shot
ready.
of something? All right. Here we go. If data science didn't exist, what other job would you hold?
Economist.
What's the best flavor of ice cream?
Anything with peanut butter.
If you could have one possession on a desert island, what would it be?
Fire. Can I possess fire?
We all wish we could. Who was your inspiration growing up?
My mom. Yep.
That's awesome.
Single woman. Single mom.
Yep, ditto.
So,
I'm with you.
Sorry.
What's your favorite musical group?
Ray LaMontagne.
Oh, all right. What's the best quality about 8451's company culture? Single
flexibility.
All right, love it. What advice would you offer to a novice data scientist?
Make lots of mistakes.
And if you invented your own programming language, what would it be called?
Mr. Darcy.
I'd like to know why, but I think we're good, right? We didn't quite make it. I got to get better at this. All right, and Brad, thank you very much. That is the end of this episode of The Uplow'd by 8451. We really appreciate you being with us, and we will see all of you, our loyal listeners and viewers, on the next episode of The Uplow'd by 8451. This has been your host, Dan O'Keefe.
Millen here. That's it for this month's episode of The Uplow'd. We We hope you enjoyed it and hopefully learned something new. Remember to give us a like and share your feedback. Until next month, stay curious.